Hydrogen is the most common element in the entire galaxy and might just be what's powering the next generation of heavy trucks. Today we're going to talk about why it works, how it works, and when it works, and of course we'll be building a fuel cell of our very own, or at least part of one. Let's get started.
Throughout this video, pay attention to the modular blue box sitting below the cab of the semi-truck. This is where all the hydrogen magic happens, and it's what we're going to see inside of today. It's not an engine, it's not a motor, it's a hydrogen fuel cell, able to pull energy from hydrogen gas, combine it with oxygen while moving a fully loaded semi, with our only exhaust being water. Today we have very exclusive access to the Hydrotec Fuel Cell Lab at the Pontiac Engineering Center. They've been developing and using these hydrogen fuel cells for the past 50 years.
To get the hydrogen in a usable format for regular people out in the wild, we have something called the Hydrotec Fuel Cell Power Cube. The one behind me is instrumented for testing, which gives us an inside look of how it works. The black box here is the brains of the operation, and we have the hydrogen inlet here, the high voltage out here, and regular air with oxygen coming into this side. Since this isn't a testing facility right now, it looks a little bit complicated and wires are everywhere, but in the real world, it looks like this. Behind me is a Hydrotec power cube installed in a real world situation here on this semi. The cubes are modular though, and can be installed in locomotives, airplanes, being power generators. It's cool that it can be used in multiple applications. Today though, we're focusing on the semi-truck. This is an engineering development vehicle, but it's a great proof of concept of how the Hydrotec power cubes work. There's one of these on either side, each of which provides 77 kilowatts worth of power. The hydrogen is stored behind the cab. The fuel receptacle is right here, and if we look inside of the cab, we can see the tanks. Behind the cab there are 6 10-kilogram tanks. You might be wondering why the tanks look so weird, and that's because not only is hydrogen the most abundant molecule in the universe, but it's also the simplest and the smallest. Any normal tank made out of normal metal or plastic would act as a pasta strainer, allowing hydrogen to escape through the walls, or worse, embed itself into the tank, which would cause embrittlement. These tanks are made from carbon fiber and have a liner inside to keep all the hydrogen contained. Plus we're running these bad boys at 10,000 psi to get all that hydrogen crammed in there, so they have to be pretty substantial. So we've talked about where the hydrogen goes in, where it's stored, how it's used. How do we get power to the semi-truck? Right now the truck is at idle, being extremely quiet, with the only emissions being the water running out the bottom. The majority of the power is coming from these 2 hydrogen fuel cells, one on either side, but there is a supplemental 220 kilowatt hour battery pack underneath the cab to help with acceleration, getting up to highway speeds. These things can weigh up to 80,000 pounds, so there is a lot of power needed to drive. The propulsion is coming from 2 electric motors on the rear drive axle with some pretty impressive cabling. Obviously this is an engineering development vehicle, but it's pretty cool to see how it all works. Taking a ride, it's actually surprisingly quiet inside of this thing. We could have a whole conversation right here without the noise of the engine just rumbling. Big trucks are what make the world go round, but big trucks and the transportation industry are responsible for 30% of global carbon emissions.
And hydrogen is one way of reducing that footprint. The 6 tanks of hydrogen we saw on this truck can be refilled in about the same amount of time as a regular gas tank, and gives this semi about the same range as a regular semi. I might be getting a bit ahead of myself though. Let's start back at the beginning.
Behind me is a tank full of liquid hydrogen. The hydrogen we use inside of the vehicles in the power cube, however, is gaseous hydrogen. In order to change from a liquid into a gas, it goes into these expansion tubes. When hydrogen changes forms, it expands 850 times. The hydrogen is stored at negative 250 degrees Celsius. So as you can see it running through the tubes, ice is forming on the outside as it expands into its gaseous state. And once it's in its gas form, then we can stick it inside of the cubes.
Liquid hydrogen is easier to transport since it takes up 850 times less space. However, gaseous hydrogen is easier to use. since it doesn't need to be stored at negative 250 degrees Celsius.
The amount of hydrogen in this tank alone can power 3,000 average American homes for one day.
If, of course, we can harness that energy. The harnessment of hydrogen comes from something called a fuel cell, and in its most basic form is this guy right here. Hydrogen gas enters from one side, and all the jiggly conduit lines evenly and equally disperse it over a larger surface area. We lay down an airtight gasket before applying the membrane diffusion medium, and I'll get to this more in a second, but basically this black layer is a carbon paper infused with platinum that helps the electrons separate from the hydrogen so we can use their energy for a bit. The maze engraved into the opposite side of the fuel cell is where the ambient oxygen enters, which then completes our chemical reaction. The process has simple ingredients, but it's still very scientifically complex, balancing the different ratios of hydrogen, oxygen, and platinum catalyst. But as you can see, just like how a small battery is able to produce voltage, as soon as I connect the voltmeter to the hydrogen fuel cell and crank up the hydrogen gas, this simple example is able to generate nearly 1 volt of electricity, using only 3% hydrogen. Inside the semi-truck, we'll be using 100%. But how do we scale this 1 volt of electricity up enough to be actually useful?
What I showed you earlier is a very small example of a full-size fuel cell stack inside of the vehicle. The reason it's called a fuel cell stack is because it has a bunch of these plates and membranes stacked up on top of each other. You can see the same air channels for both the hydrogen and oxygen reacting with the membrane on every single plate. Each one of these plates allows for about 1 volt of electricity to pass through, heading to the motor, and the surface area dictates how many amps we're able to pull out of the plate. Added up into one giant stack, there's a lot of power inside of here. Obviously, I'm not getting super close to this one since it's being tested right now, but you can see the positive and negative terminals coming out the top of the stack. And the only emissions, the only exhaust is coming out the bottom in the form of pure water. We've been given special access inside of Hydrotec's electrode build lab, and in my hand I have platinum catalyst, which is the heart of the hydrogen fuel cell.
The platinum gets mixed up into a special black, inky solution.
Just like a battery has a positive and a negative, so does a fuel cell, and we can make both of those electrodes out of this ink right here, made out of platinum.
You might be asking yourself, hey Jerry, what does platinum have to do with hydrogen? And that's a fantastic question. Platinum is a catalyst, which means when the hydrogen gas enters one side of the fuel cell, the platinum-coated carbon paper is the kryptonite that makes the electrons and protons separate, allowing us to use the electrons how we want before they meet up with the oxygen to form water. You know, H2O. In my opinion, the black ink has a very distinct smell of blueberries that have been in the fridge for a bit too long. The large selection of rollers we have to choose from all have different thread heights, which allow us to repeatably roll the solution onto paper in different thicknesses, which can then be tested to find the most optimal ink ratio configurations for the most efficient energy transmission. Science is all about repeatability, and this Hydrotec lab is constantly testing new formulations of electrodes.
I've just made my very first hydrogen fuel cell electrode.
And just like a delicious cake, once a good recipe is solidified, we can start manufacturing the hydrogen fuel cells on a much larger scale. It takes more than one piece of platinum paper to move a semi. The Hydrotec fuel cell lab is able to take a long roll of that carbon paper and send it through an accumulator, perfectly and repeatably applying the platinum catalyst solution over the surface. The platinum is applied at a vacuum, so there are no bubbles that might contaminate the chemistry happening inside of the fuel cell stack. The rollers you see here on the edge of the machine are able to move in and out to control the speed of the paper as it moves through the machine, and it gives the engineers time to splice rolls together without ever needing to stop the process. The coated paper then goes through an oven to dry and comes out the far side of the machine ready to get cut up into the hundreds of smaller segments that make up the fuel cell stacks. In the past, collecting liquid hydrogen for projects like this has been extremely energy intensive. It still is. But now, with renewable energy like solar and wind being cheaper than fossil fuels, Collecting hydrogen is much cleaner than it used to be, and the industry is just getting started. With hydrogen being 10 times more energy dense than lithium batteries, we get all the clean energy perks with none of the onboard weight, which is important for big rigs like this one. It's been pretty fun seeing how hydrogen works, and I'm looking forward to seeing more hydrogen-powered semi-trucks on the road in the future.
And there you have it, a semi-truck powered with hydrogen. Let me know what you think down in the comments. Should I make a hydrogen-powered Humvee? Thanks a ton for watching. I'll see you around.